Welcome to Computer Science 305. This is our first look at Java. I'm assuming that we all are well aware of what Java is and how it works. But regardless, we're going to go through it, and this should give us a quick intro and maybe some things that we may or may not remember from when we learned Java in the first place. So, we'll start. There's lots of things we're going to be talking about. And so Java is the language we're going to use for the object-oriented paradigm. And so one of the things that we're going to be doing is thinking about objects. We'll talk about simple expressions and statements, class definitions, references versus pointers, and then we'll get started with the actual Java language system. So for most of this, there will be no code that will be written, just more talking about Java itself as a language. So let's think about this, right? So, if we're thinking about like the screen, right, as an example, like the display on your laptop or your tablet, your computer monitor, whatever it might be, we can think of this as the screen being made up of individual single colored points, also called pixels. And so we ask ourselves, what kind of goes into making this? Well, in essence, right, each one of these, the screen itself is composed of these colored points. Each colored point has a specific coordinate within the screen, as well as a specific color. And so then we ask ourselves, well, what should we be able to do with a point, right? Well, if we're making a point on the screen, and we're not talking about just the screen itself, we have to have the ability to move the point around, right? We also need it to be able to report its current location. So we think about this, right? If we have these three different points here, we have a black one, a dark gray, and a light gray point, right? And so this one, the black one, happens to be at location 520. It's black, it can move, report its X, report its Y. And then similarly the light gray and dark gray, right? Just the only difference is the color and the coordinate. And so that tells us some things about this, right? Now, if we want to, we can then start thinking in the Java terminology, right? And this is more or less the object-oriented paradigm, right? In this case, each point itself is an object. And so in object-oriented, we always want to keep our data and our behavior, or our methods that modify that data, within the same object. And so we want to then put that data, and that data would be the three fields, right? The X, the Y, and the color. And then we have three methods, right? The capability to move or change the value of the X, Y position. We want to be able to potentially... and then we want to report what X do we have and what Y do we have. And so that's our methods, right? Functions within the object. And then we have the concept of what we call the instance, right? Instance is a synonym for object. It's just it's basically saying like the class in which we define all this, right, is the cookie cutter, and that cuts out and tells us and defines what are the things that are attributes of this class, the values specific to those attributes, and inform us the differences between instances of those classes. So we'll kind of get into that shortly here. So this is, as I said before, this is a implementation of the object-oriented style, and so we solve problems using objects, right? Basically, an object is simply a grouping, a specific grouping of data and the methods that operate on that data, right? Essentially what we're trying to do is we're trying to keep the things that are very, very closely related to one another in the same place. This is also what's known as the single responsibility principle, which is a cornerstone principle of the object-oriented design paradigm. Basically saying that no class, no method should have more responsibility than a single major responsibility. So now we also have to know that we have to understand that it's not that the computer knows how to move the point, but rather the point knows how to move itself, right? That's the difference. So before, in the functional, or even in the when we were working with Ruby in the more iterative paradigm or imperative paradigm, we had code that knows how to do something to given data, right? And so essentially it's saying that the computer or our program knows how to do something. In this case, it'd be knows how to move the point. But we read in the object-oriented paradigm, we read that the point knows how to move itself, and then that's why we keep the methods inside the actual point. Now, on the other hand, we also have object-oriented languages. This is the way we think in OO and the way we program in OO, right? And the goal of this is to very fine-grained modularity of behavior and data. And so, if we can all recall in Java, when we want to build something, right? For example, this class point, right? First thing we have to do is we have to define it's a public class point. It's in the file point.java. And then we're going to define our fields, right? Our fields are just the variables defined within the class outside of any method. And those are typically private because we want to incorporate the good design principle of encapsulated data. And then we define our methods similar to how we define a function within the class. They typically are public if they're instance methods and a part of the main interface of the class. And we know that, so if we define them as public, then it's the return type. It's either some primitive like int or an object, or void, right? Void meaning that it returns nothing. And then we give the method name, followed by parentheses. If the parentheses are empty, it takes in no parameters. If there's something in there, it's usually defined as a type, followed by a variable name. And that gives us a method definition, right? And then inside there we can do anything. If we have a return type that's not void, then we must return something with the return keyword. All right, so I'm assuming that we all knew all that, and if not, this is a good refresher. We'll dive deeper into this shortly here. So the next step is we want to talk about simple expressions and statements. So I'll leave that to the second part. All right. Well, hopefully I'll leave it at the second part, and